Hello guys, what's up? Welcome back to the 5 algebra questions a day workout challenge. So today is day 2 and we'll continue on with algebraic fractions, alright? So how it works is that there will be 2 basic questions, 2 intermediate questions, and followed by 1 advanced question, alright? So we will always start off with the easy one first. If you feel like trying this out yourself, you can just feel free to pause the video and work out your answer and then later compare with my answer, alright? Okay, so let's start off with the question on the left-hand side of the blackboard. Okay, so we have this question over here. So what we want to do is that whenever we see a bracket, we will always want to expand it first, okay? So since the numerator, we're not doing anything about it, so we are just going to repeat the numerator. Okay, I'm not going to touch it. I'm just going to repeat it. And now I'm going to expand. Remember that when you are expanding, power of 4 is being multiplied, okay, to every single variable. So 2 to the power of 4, it basically means 2 times 2 times 2 times 2. And this will give me 16, all right? It is not 2 times 4 gives me 8, but it's 2 times 4 gives me 8. It's not like that. It's more of like 2 times 2 is 4, right? Take that 4, multiply by 2 again. You get 8. That 8, you're going to multiply by 2 to get 16. So 2 to the power of 4 is 16. If you're not sure, just always double check with your calculator, all right? So I'm going to put 16 over here. Then I will have h to the power of 4, j to the power of 4, and k to the power of 4. All right, and what I'm going to do is I'm going to move on to step 2 to use algebraic cancellation to cancel out the common variables. Okay, so I will start off with the numbers first. So I'm going to divide both top and bottom by 8. And then I'm going to cancel h cubed. All right, so I'm left with 1 over here. And the j I'm going to cancel. And therefore here I'm left with a j cubed. And k to the power 4 cancel with k to the power 4. This will give me like nothing. All right, so it's fully cancelled for my k. So now it looks very messy. I'm just going to rewrite this thing. So I'll get 1 over 2hj cubed. Okay? All right, now let's move on to the right side of the blackboard here. Okay, so I have gh minus h squared over g minus h, the whole thing bracket square. Okay, so I have to observe my numerator. Okay, there is actually a common factor over here. So whenever there's a common factor, I have to always perform simple factorization. Take out the h. I'm going to take gh to divide by this h. I left with a g. Okay, minus h squared divided by h is h. You should get something like that. Always remember to expand and to double check if you get back the question. So yes, I do get back the question. Over, okay, I'm just going to repeat this thing again. Please do not expand, because what most kids will do is that when they see something like this, they will just, oh yeah, I know this is an algebraic identity. I'm going to expand it to g squared minus 2gh plus h squared. It's wrong, because over here what we try to do is we are going to simplify, we are simplifying and expressing this in its simplest form. Okay, express this algebraic fraction in its simplest form. And always remember that our main goal is that we want to cancel something. We want to do algebraic cancellation. And so if you expand it out, basically there is nothing you can cancel. So we have to leave it in a factor form like this, just leave it like that, so that now we can actually happily cancel this, like this, and I'm left with a power of 1. Okay, so here I will be left with h over g minus h, and I'm done. That's all. Very simple, provided that your concepts are very clear, all right? Okay, let's continue on with the two intermediate algebra questions, all right? So let's look at the left-hand side, c squared minus 4c over c squared minus 16. So what we're going to do is we're going to observe. For the numerator, okay, it's basically simple factorization, all right? Because I can see that there is like a common factor over here. All right, so what I'm going to do is I'm just going to take out the common factor, c squared minus c, divide by c, sorry. This gives me a c inside, right? Just let me write a little bit clearer. And then I have a negative over here. 4c divided by c gives me a 4. And then I just expand to check if I get back the question. Yes, I do. And then now I can safely continue. Okay, the denominator c squared minus 16 is actually a algebraic identity. Okay, there are altogether 3 algebraic identities to get ourselves familiar with or memorize if you can. All right, and the 3 are basically, I mean, we talk about this one here, which is what I call algebraic identity 3, AI3, is actually this one. So it looks something like that, okay? A squared minus B squared, it will give me A minus B, A plus B, okay? A minus B, close bracket, open bracket, A plus B. This is how it looks like. And you can see that there's a similarity over here, this and this thing, because basically C squared minus 16 is actually equals to C squared minus 4 squared. You can see that 16 is actually a perfect square. Okay, 16 is actually 4 squared. So the number 16 is what we call a perfect square. All right. So therefore, I know that I can use this algebraic identity number 3, right? Okay, so what I'm going to do is I'm basically going to, okay, I know that my A is basically C over here. Okay, so this thing will be C minus, you just imagine that you do a square root like that. Can you see? I just do a square root over here. So it's square root 16 is 4. Close the bracket. Open another bracket. I'm just going to put C plus 4. Okay. And now we go to step 3. I'm going to do algebraic cancellation to cancel out the common factors. C minus 4 and C minus 4. And therefore, I'm left with my final answer, and that is C over C plus 4. Okay, so next we go to the right-hand side of the whiteboard. Okay, so we have this thing over here. So first thing is that I can see that there is a common factor for my numerator. So I'm going to take out my common factor. Over the denom is, you can tell that it's a quadratic factorization because it looks like this thing. When you see an expression that is expressed in a way that is a x squared plus bx plus c is what we call a quadratic, okay, quadratic equation, quadratic expression. So for all quadratic expressions, we're gonna use like either the branching method, okay, or we can use the cross method that looks like this. So depending on which country you're living in, just use the method that you are most comfortable with, or the method that you have already got it, that is already drilled inside your head. Okay, so I'm going to put 3f squared here, minus 13f is here, plus 12. So this is, okay, 3f, okay, multiply with f here. And then I'm going to get my factors for 12. So this one is like 1 times 12 Okay, 2 times 6, I have a few, like 3 times 4 as well. Okay, so we are always going to try the last one because most of the time, like 90%, okay, it's gonna be like the last option, the last factor that you listed out. Okay, so for this, I'm going to use like put 3 here and 4 here. And then I will multiply them diagonally. Remember, it's always a diagonal multiplication. 3f times 3 is 9f. And then f times 4 is 4f. How do I get negative 13f? Is I obviously have to be negative 4f, negative 9f equals to negative 13f. Okay, so this is like your integers. Okay, negative plus negative will give me even more negativity. All right. Okay. So carry forward the sign. I have negative here and negative here. So this will become my two factors are 3f minus 4f minus 3. And I can see already that I can cancel off something. So always anticipate that in all the questions, there is gonna be some sort of like cancellation. If you are not cancelling out anything or not cancelling out any factors, it means that high chance you got it wrong and you have to redo. Okay. So this is my final answer. All right, now we come to the last question that is this advanced algebraic fraction questions over here. Okay, so we have a fraction multiplied by another fraction. You can see that the operation over here is actually a times, okay? But it's actually very simple to do, okay? For multiplying of fractions, multiplication of algebraic fractions, what you have to do is the first step is that we're going to do what we call X-Men or cross multiplication. So what is X-Men? Because this thing to me is actually looks like X, right? So to me, it reminds me of X-Men. Okay. So what I have to remind myself to do is that I have to multiply it diagonally, cross multiply it diagonally. So anything that is a cross, like a diagonal, I can cancel out any common variables. Okay? So for example, like I have a k here, I can cancel out. So always remember to cancel out the smaller variable. Like k is smaller. So the smaller one is always cancel out. The bigger one will have like a remainder. So over here, I'll cancel out the power. Left with a k to power 1. And then like y square, fully cancel it out. And then here I'm left with a k square, y square, sorry. Okay. And then here I have 9 and 12. I'm going to divide both sides by 3. Okay, so I have 3 and 4 respectively. H square fully cancel out. Here I'm left with a 1. Okay, and the x square and y I cannot cancel, so I'm just going to leave it there. And what I'm going to do is I'm going to rewrite this fraction because it's very untidy now. So I'm just going to rewrite it neatly. Just make sure you do it very carefully. Okay, and then times, yep, there's still a times there. Okay, 5ky squared over, okay. What I'm going to do is I'm going to multiply the two fractions in a straight line. Okay, so what I mean is that I'm going to just multiply them like this, numerator multiply numerator, and the denom will multiply with the denom. So I will get pretty much something like this. Okay, 3 times 5 is 15. H, okay, 1h, h to the power 1, x squared, k, y squared, okay, over 4 times 4 is 16y. At this stage, just make sure that when you multiply, you are only strictly going to multiply them in a straight line. Okay, so there's no cheating or anything. Just make sure you multiply them in a straight line. Numerator times numerator, denom times denom. And you will get something like this. Okay, so I'm going to draw a arrow. Okay, and over here, what I can see that I can actually cancel out some stuff, right? Because there is still some common variables which allows me to cancel. Okay, so I have to cancel some stuff. For example, like the y over here, I can fully cancel with the y here. And basically that's it. I cannot really cancel any other things. So my final ANS, my final answer, so I'm just gonna rewrite it. Okay. Over 16. So there you go. This is my final answer. All right, so what happens is the arrangement is like different from mine. For example, if your answer, right, your ANS, you present it like maybe 15 and you have like h and then maybe k is here, y, and then x squared. Is this still considered like correct? The answer is yes, because basically all these are like multiplied together, so the arrangement doesn't really matter as long as the powers are correct. Like you have h to the power 1, k is 1, y is to the power 1, and x squared, but not other powers. As long as your powers are all correct and your numbers, your coefficients like this, 15 is 15 and 16 is your denominator is 16, then definitely your teacher will mark you correct. All right, so that's it. Okay, basically that's all. So if you find this very helpful, please do smash the like button and subscribe to my channel. I hope to see you again.